Hello everyone, my name is Matthew and in today's video we'll be learning about merge sort algorithm in Java. First, what is merge sort? So merge sort is a divide and conquer algorithm invented by John von Neumann in 1945. It is more efficient than other sorting algorithms such as bubble sort and insertion sort, especially when dealing with large datasets. The merge sort algorithm breaks down a big problem into smaller pieces, then solves these subproblems recursively or repeatedly, and combines the solution to solve the original problem. The main takeaway is the theme of divide and conquer. So, how does it work? There's two simple steps that you could think of when dealing with merge sort. So the first step is to divide the unsorted list into n sublists, each containing one element. So for this example, we have an array with 7 elements, and we're going to divide it until we have 7 different arrays, each containing one element. Then the next step is to merge the sublists adjacent to or beside one another to produce new sorted sublists until only one sublist remains. And this will be your sorted list. So we're going to merge until you have a final array, which would be your sorted list. Here is the code for merge sort. So we have 3 variables labeled L, M, and R. L standing for left, M for middle, and R for right. Then you're going to create temporary arrays to store the values when dividing and merging. These two codes are only when you're dealing with an array that has an odd amount of elements. This code over here finds the middle and divides it continuously. Then here the driver method is the main code that will print the given array or the starting array. Then it'll call the merge sort method, and then it'll print the sorted array on the next line. Let's look at an example to help understand merge sort. So in this example, we have another an array that has 7 elements, and we're going to divide it until we have 7 different arrays, each containing one element. Then the next step is to merge back the arrays and comparing the adjacent arrays. So comparing these two arrays and so forth. Now, the next step for here is to compare the first element of the first array with the first element of the second array, like this. Then comparing the first element of the first array with the second element of the second array, and then comparing the second elements of each array, and then bring down the 8. Then doing the same thing until you get the final sorted list. Let's look at the big O runtimes for the best, average, and worst case complexity. So the best case complexity is when the array does not need to be sorted, as it's already sorted. So in this case, big O runtime for best case complexity is big O of n times log n. Next, the average case complexity is when the array elements are jumbled, similar to the previous example. The big O runtime for the average case complexity is big O of n times log n. And the worst case complexity is when the array elements are in reverse. So instead of being ordered from lowest to highest, it's ordered from highest to lowest. And so the big O runtime for worst case complexity is O of n times log n. Let's look at some real-life applications. Some real-life applications include sorting large data sets of users' information for social media platforms, organizing books in a library based on the title name, author, or year published, organizing shoe sizes in a shoe store, or sorting students' records based on the name, the year, or their grades. There are many other real-life applications, but these are just a few. In this example of a real-life application, we are looking at 9 students' grades, and we want to order it from lowest to highest to see what students are doing and what students are not doing well in order to help them. So what merge sort will do is it'll take the original array that we see in front of us, and then it's going to divide until it has 9 different arrays, each containing one element. Next, it'll merge from beside, and then it'll give us the final sorted array that looks like this. Thank you for watching. I hope you found this video insightful.